Hi, ChemStars. Welcome to your Chapter 1 practice, pages 5 and 6. So if you're checking this work, it means your pages 5 and 6 should already be filled in. You've already watched the flipped video lecture, and you also have done the physical chemical changes lab, or you've watched the YouTube video of the lab. Okay, so on these pages, we're going to be looking at physical and chemical properties, and also intensive and extensive. So let's just read this background and highlight the important things. So physical properties, it can be observed with the senses and can be determined without destroying the object. This is things like color, shape, mass, length, density, specific heat, and odor. Those are all physical properties. Chemical properties, on the other hand, it's all about how something reacts with something else. When you observe it, the original substance is changed into something new. So for example, iron rusts. That's a chemical property. We don't have that same iron left over anymore. Rust is something different. So the iron reacted with oxygen and the original metal is gone. All chemical changes include physical changes as well. Then the other part is intensive properties do not depend on the amount of substance, while extensive properties, they do depend. Okay, so let's go through first and just look at physical or chemical. I'm just going to look at things. So I'm just going to go through this list and look for things you can observe without destroying the object. So red color, you can observe that with your eyes. It's a physical property. Density, well, you can measure that without destroying it. Mass, just put it on a scale. Solubility is maybe a trickier one because you have to dissolve something in water. But think about this. If you dissolve salt into water, do you still have salt in water? Yeah, you do. It's a physical property. It's not reacting with anything else. Okay, now I see that keyword reacts. I'm going to skip that. Supports combustion. I don't know what that means. I'm going to skip that too. Bitter taste. This one's another one, might be a little bit tricky. So if you taste something, I know that when you eat it, you're destroying it. But just if you actually taste something, are you changing what it is? No. So bitter taste is a physical property. Melting point is also physical. You can melt ice into water. It's still water. You can freeze that water back into ice and it's the same. Okay, react, skip those. Hardness, how tough something is, how much it resists scratching. You can test that without destroying the substance. Ooh, energy release when burned. That sounds chemically. Ooh, that sounds really chemically. Luster, that means how shiny something is. And odor. So I went through this really fast and I just looked for everything that seems really easy to say, yep, those are definitely physical. Okay, so physical, oops. Physical. I think you get the idea here, right? So now we want to go back through and just make sure everything that I haven't said is physical is actually a chemical one. Okay, so let's review the definition of a chemical property. How it reacts with something else. It's changing into something new. So let's scan the list of what's left over and let's see if those all are chemical. Okay, reacts with acid to form hydrogen. That's something new. That's a chemical. Supports combustion. Well, what's the word combustion mean? If you're not sure, you can look it up. Combustion means fire or how something burns. So we're talking about how it burns. If you burn a piece of wood, is it the same anymore? No, it becomes like ash or charcoal. So that one is definitely going to be chemical again. Reacts with water to form a base. So chemical reacts with another chemical to form something new. Chemical. Reacts with a base to form water. Same idea there. Okay. Energy released when burned. If you're burning something, you're destroying it and making something new. Talking about the energy release, chemical, and can neutralize a base. That's talking about how something's interacting. So that's all chemical. Okay. The ones that maybe weren't as intuitive were our solubility. Maybe you weren't sure about the bitter taste, but those are definitely physical properties. Okay. So that was the easier part. Now we have to look at the intensive versus extensive. So intensive is innate to the substance. No matter if you have a little Hershey's Kiss or a big Hershey's chocolate bar, the chocolatiness of it is intensive. It's innate. It all tastes the same. It all smells the same. It all has the same formula. But if you compare a Hershey's Kiss to a big giant chocolate bar, things that are different are extensive properties. Things like the size, the mass, the volume, the surface area. So let's look at these. If you see Let's go blue for intensive. If you look at the red color, if something is red, does it matter how big it is? No, it's still going to be intensive. Maybe I should, let's see, I'll use blue pen for this. So I'll just say I for intensive. Density. This one's tricky. We're going to do a lab with this next chapter. Density is also intensive. So if you take a large sample or a small sample of the same material, like gold, it'll still be really heavy for its size. Now mass depends on size. I'm going to skip over that one. Solubility, that's another intensive one. No matter how much salt you're trying to dissolve, it'll still dissolve at the same rate if you have the same volume of water. Bitter taste. If you taste some like really, really bitter coffee, if you take a big sip or a little tiny sip, it'll still taste the same amount of bitter. Melting point, all water starts to melt when we get to 32 degrees, or all ice starts to melt into water at 32 degrees. Let's see, hardness. That's also intensive because if you try and scratch a big section of your nice countertops, it'll be the same as scratching a little section. Luster, how shiny something is. That's usually intensive. There's some minerals where they actually change, but don't worry about that. And then odor. So think about like a whole tray of chocolate chip cookies and one chocolate chip cookie. Do they both smell the same? Yeah. So let's go back and the things we haven't said yet. I'm looking at these physical properties. Let's see what the extensive ones are. The size of the sample matters. So mass, that's literally the measurement of how much matter you have. That's extensive. Okay, I was just going through all the physical ones first. I don't see any other extensive ones. Let's give some examples. Extensive, it's things like mass, volume, also could be like a surface area. Okay, now I skipped over the chemical ones because I want to kind of treat those together. So the chemical properties are all about how something reacts with something else. So how it reacts with something else. So if we react with acid to form hydrogen, does it matter how much of that substance I have? No. So all of these chemical properties, these are intensive. They are innate to the substance that I have. Okay. So if we know it's chemical, we also know that it is intensive. Okay. If you're a little bit confused on that, just make sure you take some time, look over those definitions. Okay. Go back to your notes, check your blue book, and you'll be doing fine. Okay. Let's go to page 6. So let's talk now about physical and chemical changes. So in a physical change, the original substance still exists. It's only changed form. So maybe ice has melted into liquid water, or liquid water has boiled into steam, or maybe I have a piece of paper and it's still paper, but now I've shredded it up. That's different than a chemical change where a new substance is produced. There will always be an energy change. Okay, maybe I react hydrogen gas and oxygen gas. I burn them and I make water vapor. That's something new. Or maybe we burn a candle and now we have smoke and a burnt wick and new gas is produced. So we're going to go through and classify each of the following as a physical change or a chemical. So I'm going to take a quick pass through all of these. I'm going to highlight things where I think it's still the same stuff. Okay, sodium hydroxide dissolves in water. Whenever something is dissolving, we can always get it back if we evaporate the water off. Okay, hydrochloric acid reacts. Ooh, that seems chemical. It will come back. Sodium is sliced in two. It's still sodium, right? I just have two smaller pieces now. Okay, water is heated and changed into steam. Well, the steam is still water. It's still H2O, so that's a physical change. Ooh, some chemical called potassium chlorate decomposes into potassium chloride and oxygen. Ooh, that's new stuff. Iron rusts. There should be an answer right there. Is rust the same thing as iron? No. You wouldn't want a car made out of rust. You wouldn't get it very far. Okay, when placed in water, sodium pellet catches on fire. That's definitely an energy change. And a new gas is, nope, doesn't seem physical to me. Evaporation. That's the water cycle. If water evaporates, I can get it right back if I cool it down and condense it. Ice melting. Ice is H2O. Liquid water is H2O. It's the same thing. Ooh, sour milk. You want to take a big swig of sour milk? No, that's something new, something different. Here's that dissolving word again. Sugar dissolves in water. Yes, I can get the sugar back if I wait long enough. I could get some rock candy. We'll do that later in chapter 12. Okay, wood rotting, like an old log in the forest that's fallen down. Is that the same as the tree? No. Pancakes cooking on a griddle. Now, pancake batter, is that taste the same as pancakes? No. Grass growing in a lawn. That's confusing. We're going to come back to that one. A tire is inflated. All I'm doing on that one is taking air from outside and putting it in the tire. No change. So that's a physical change. Digesting food. Nah, I think that's something different. Water absorbed by paper towel. It's still paper towel and it's still water. Okay, so that was my first pass through, looking for the easy ones that I know are physical. That's a good technique on tests or quizzes. Go through the easy ones first, kind of overview them, then we'll go back and find the chemical ones and discuss the ones a little bit trickier. Okay, so chemical change, a new substance is produced, energy changes. Okay, hydrochloric acid, potassium hydroxide, salt, water, heat. That's definitely a chemical change. I had 2 ingredients, I get 2 new products, and there's a heat, there's an energy change. Okay, now here's one chemical. It decomposes into a new chemical, an oxygen gas. Definitely chemical. Iron rusts. You could stick your finger through like a rusty spot on your car. You wouldn't want your whole car made of rust. They're not the same things. That's something new. Okay, sodium pellet put with water catches on fire. We're going to see this in chapter 5. It's pretty cool. And we get a new gas. Definitely chemical. We're getting something new. There's a big energy change with a fire. Now, milk sours. This is chemical because sour milk is not milk. You don't want that on your cereal. It tastes different. It smells different. It's gross. Some bacteria or other little critters have gotten in there and changed the composition. Wood rotting. That's another chemical change. It's going to rot down into soil. So not the same thing. Pancakes cooking on a griddle. We have a chemical change. You can see the bubbles forming when you cook your pancake. A new gas is forming. The smell changes. The color of the pancakes changes. And they taste different. The batter doesn't taste the same as a cooked pancake. Now, these last 2 you got to think about a little bit. Grass growing in a lawn. Is that a physical or a chemical? When we say the word growing, what's actually happening? Grass is taking nutrients, water, sunlight, carbon dioxide, undergoing photosynthesis and producing sugars and new stuff to become new grass. So we're taking basically water and sun and getting grass. That's definitely going to be a chemical change. Okay. And how about food digested in the stomach? If you had Chick-fil-A for lunch today, does that Chick-fil-A change? Yeah. When you digest it, your body breaks it down into new substances and that becomes your energy to move and do all your chemistry homework. So digestion is always going to be a chemical one. Okay, so I hope after these 2 pages and after looking at the lab, you have a pretty good understanding of physical and chemical changes. If you disagree with any of these, do a little bit of research and come to class prepared to defend your arguments. Okay, I'll see you later, Chem Stars. Don't wait to be great. Bye.